Hello everyone, welcome back. This is going to be our lecture 2 for class 122, 122, 122, depends on whatever you want to call it. So I'm going to cover chapter 4 and potentially 5. So we'll see as far as we can get. It really depends on the pace though. What I would do is under the chapter lecture 2, I will put the chapter numbers in Blackboard so it's easier for you to know which chapters we're covering. Because even though this is chapter 4, I still feel the sessions, or I should the topics in here are still basic, introductory. But nonetheless, we'll follow the text, and if anything, it'll be very easy for you, or it's going to be a refresher. The topics that I'm mainly going to cover are algorithms, pseudocode, control structures, if then else, multiple if and else's, looping structures, talk a little bit more about algorithms, operators. Now, this keyword operator, I'm calling it a keyword, it is rather unique. Algorithm is, there are specific built-in algorithms that we're going to get to later on, but the way the book talks about algorithm is your algorithm, your approach to the problem. So it's more like a solution to a given problem. So given a problem, you're going to come up with a solution that says, okay, I'm going to enter this number and take in this input and then do this kind of calculation and have this kind of looping structure in it to get user the final result. That whole exercise is known as, called as algorithm. But later on, in this book, excuse me, and in the other books, algorithm will mean typically mean it's still a solution, but it's gonna mean slightly different than what book's telling you right here. So don't get confused. Think of algorithm as a solution. Okay. Next up is pseudocode. So when you are given a problem that I was talking about, let's look at this. Okay. Algorithm, pseudocode, flowchart, all of this is, it's all a depiction of a mental note. In my office, I typically have a whiteboard. I've been working from home for a while now, but typically I have a whiteboard, and given a problem or a customer need, I'll talk through the system design. What is my solution going to be? Or what are my steps? Okay, and I just write on the board. Sometimes it's in this boxes and squares, sort of. Sometimes it's literally writing down step one, step two. I tend to write in terms of step. I don't say it's step one, step two, but I say, okay, I'm going to take in the input, I'm going to do this sort of calculation, this sort of looping, and these are the edge cases, and this is what I'm going to end with. So all these mental notes that you have, you're gonna put them out on a piece of paper, board, or whatever, and that ends up being your flowchart or your pseudocode. And we call it system design. These system design in real world is very, very important. I tend to spend the most amount of time up front when I'm designing the system, because you can talk through the input, the output, the type of logic you're going to use, and very importantly, what are the edge cases? How is this program going to get tested? Well, what if the user doesn't enter in anything? Or what if he enters in an invalid number or out of bound number? What's going to happen? This will actually dictate dictate what the program is going to be like. Okay. Okay. I hope the pseudocode part is clear. You might get tested on this, right? I would say come up with a pseudocode for this, or how do you come up with the pseudocode? Uh, it's a common question, but the idea is to get your thought process. And the other thing I ought to mention is, even in the interviewing process, especially for a position of manager, or director, or above, they tend to ask people for system design, and typically it's pseudocode that you're going to be writing. For higher positions, you don't write code yourself, but you tend to manage it. Like now, I manage code. I'm in system design. I do code reviews as well, but system design I seem to spend most amount of my time. So if it isn't clear, this is one of the key and most important aspects of programming. Now let's go in and jump in and talk about the looping structure. Looping is so important because one thing it gets you away from is repetitive typing of code, um, or it's branching, or if it's if then else. If the user enters this, I'm gonna do this. Else, I'm gonna do this. That's what it means. And there are three types of if else. One is if, and then, hey, if the user did this, I'm gonna do this. The other one is if the user entered in a negative number, I'm going to do this. Otherwise, I'm going to do something else. And then there's also nested if that you call it. If else, if else, if else. And all of this is actually mimicking um, or controlling what the program is going to do. It's kind of like, okay, if I asked you for $100, you go and check into your account and you say you have $100, yes or no. If I have it, then you go into your account. So look at this example, right? I need $100. I go into my account. I check if I have $100. If I have $100, I say yes. Else, I say no. I'm talking as if it's in the pseudocode, but hopefully you get the point. Right? This is still if then else methodology, but this is multiple if else, etc. that's in there. But you shouldn't be getting confused. This is just a control structure of C++. Now, let's walk through some examples. Um, Look at this one. I've got just one if in there. So as I was telling you, um, I ask the user for a number, and I say, I take in the number. If the number is greater than 0, I say you entered a positive number. And then watch the statement after that. It says this statement is always executed. So what this means is anytime I run this program, I ought to see this message. But the number greater than 0, you're only going to see it if the entered number is greater than 0. Right? You entered a positive number. What if I do this? It doesn't. Anything? How about how about if I just hit enter? It's still waiting for the input. Now in this this is a simple if, right? You're gonna be thinking, there are other possibilities of user entering data. How about if I do this? What it actually did in the background is it looked at the integer representation of a and then compared that with 0, and it came back. But the point I'm trying to make here is I am not catching or thinking of all the scenarios for the user input. So this is just one if. Now let's look at this. This next example here, I have an if and an else in there. However, in this example, what I'm doing, I look at if number is greater than or equal to 0, then I say you entered a positive number. Otherwise, I say you entered a negative number. Now let's see this one in action. You entered a positive number, and watch out for the last line. This line is always executed. It is outside of any looping or if structure, so it's always going to get printed. Q. You entered a positive number. Now if I entered in a negative number, you entered a negative number, right? Because I've got if and else in here, so I've got a little bit more meat to my program in this one. enter a positive number. I mean, you can one can argue that zero isn't positive, isn't negative, it's just zero. But I mean, for simplicity's sake, they said anything greater than or equal to zero is considered a positive number. It depends on how you define it. So you control the if and then if else structure. Okay, so we're building on if. First one just had an if. This one has an if else. Now you can kind of guess where we're going with this. If else, right? Um, Now in this case, I take in an integer. If it's greater than zero, I say it's a positive number. If it's less than zero, I say it's a negative number. Otherwise, I say zero. So this is catching that third case that I was talking about, zero, because zero is is neither positive or negative. I'll enter zero. You entered zero. You entered a positive number. You entered a negative number, right? So this way you are you are controlling this. Now, what if I take this else out? What do you think is going to happen? Program will still compile, but you're not going to get it's not going to recognize the zero at the end. Let's continue on. Now, the last piece of if then else saga is nested if. Uh, in this case, I take in an integer. If it's not equal to zero, right? Could be less than zero or greater than zero. Then I enter this loop. And this looping, this if structure goes from line 13 to line 23. Then there's a further if condition in there. That if number is greater than zero, I say number is positive. Otherwise, I say number is negative. Otherwise, uh, then I say the number is zero and is neither positive or negative. So you actually have nested if statement in there. So I ask for an integer to be input. Come on. All right. Maybe let me just run it again. 6. The number is positive, and then outside of if else block there is a final line which says this line is always printed. So and watch how look at the 0. The number is 0 and it's neither positive or negative. This is another flavor of catching 0. In the previous one we said if it's greater than 0 or less than 0, um, otherwise finally if it's 0. But here we're catching 0, this edge case, via nested if. So there are different ways of executing your solution. I'm not going to talk about the readability, maintainability of the code, because when it comes to readability and maintainability, things change a little bit. But you can come up with a solution any way you want for now. Hopefully those examples are clear. Okay, so now let's go ahead and start talking about while loop. But before I actually show you examples or discuss a little bit about while loop, there are 3 types of looping structure in C++. There is a for loop, there is a while loop, and then there's a do while loop. Then there are other ways of controlling the structure of the program or the control of the program via switch statements, breaks, etc. But those we won't cover. I mean, right away. I'll get to it. But immediately, what I do want to jump into is the while loop. Then go ahead and talk about the do while loop, and then come to the for loop. Because I feel if you know about the for loop first, you'll skip the other 2 looping mechanisms. That's what I would have done if I knew about the for loop first. Okay, so the way while loop works is the book calls it sentinel based looping. So while there is a so you this is what the syntax looks like. While, and then in parentheses there's a condition, and then there's the body of the loop, what you want to execute. Um, so in the while loop, you give it a condition, and as long as the condition is true, you're gonna stay in the while loop. You're not gonna come out of it. If you say I equals one, and then if you're checking if I is equal to one, and you never change I, you're always gonna stay in the while loop. Okay. Let me go over some examples here. Um, so here I have a program that's gonna print numbers from 1 to 5. Um, we start off I equals 1. If I is less than or equal to 5, then I'll put I. Oh, the increment operator. There's something that the book wants me to uh, mention first. So I'm going to pause there. I'll come back to that example. But there's one thing. Why is this not loading? Come on. Um, there is a shorthand representation of the operators. Okay. There was it. 4, 3, 4. Go to the fourth one. Compound assignment. Like I said, I'll go back to there. But here's something that you ought to know. So you can say C plus equals D minus equals E times equals divided equals modulus or percentage equal. Um, so let's assume you've got C equal to 3, D equal to 5, E 4, F6, and G12. If you use this representation plus equals, all it means is if you say C plus equals 7, that is C equals to C plus 7. D minus equal, D equals D minus 4. E times equal, E equals E times. So you're going to repeat the same variable again, right? And then do the operation that it tells you to. Makes sense? Um, and then you've got I thought I mentioned the pre-increment and post-increment. So what this actually means is I equals I plus 1. That's what this is. Okay? So in this program, I output I, and then I say I equals I plus 1. They continue in the same loop. I say as long as I is equal either less than or equal to 5, I'm going to come in the loop. Okay, second time that's true. The second time when I come in, I is actually 2 because I incremented it, right? It says 2, and then I equals 2 plus 1. Now it's 3. Check the condition again. Is 2 less than or equal to 5? Yeah, it's still less. Then you output I. Watch what happens. There you go. There you see the numbers. From 1, 2, 3, 4, 5. Okay? So that's the while loop. Here, I'm going to go through another example. And I start off int number, I declare a number, and then I have a sum. So this is a program to find the sum of positive numbers. So I'm going to keep taking an input from the user. I'm not going to do a whole lot of, I'm not going to do error checking at that point. I'm just going to take a number from the user. If the number is greater than or equal to 0, so the only check I'm going to do, I'm going to make sure it's a positive number, but nothing else. If that's the case, sum equals to sum plus number, right? So this. And then I ask user to enter a number, input the number, And after I've gone through the whole loop, the expectation is that I would know the sum at the end. Okay? What else should I point out? No, I think it's not warranted. So I say number. The keyboard. My keyboard on computer is acting a little funny, but you get the point, right? Let's try one. There we go. 2, 3, 4, 5, 6, 7, -1. There you go. So it kept asking me for a input until I inputted something that's not greater than or equal to 0. Basically, as soon as I entered a negative number, it exited the loop. Otherwise, it's keep going. 0, -1, and it stops. Okay? So, the benefit of this is you don't have to keep you save number of lines of code, and your input and output is controlled, and it makes the code readable, right? Assuming you understand the shorthand representation of the plus equals 2. And as you saw from the textbook, you can use any other operator there. You just have to expand it in a similar manner. So if you had sum minus equals number, then all it is sum equals sum minus number. So hopefully that program is clear. The next thing I wanted to cover was, let me do this, remember I said I'm going to go over the while loop and then the do while loop. So let me show you what the do while loop does. The do while loop is slightly different. Is in while, first you check for the condition right away. But in do, you'll do it right away and then you check while. So you'll check the condition at the end. So in this case, as long as I is less than or equal to 5, I'm going to keep outputting I. And I'm going to keep incrementing I by 1. 1, 2, 3, 4, right? So go ahead and run. Now watch. One thing to keep in mind is I'm going to make this 5 on purpose. How about if I made it 6? See, 6 shouldn't satisfy the y. The condition is going to be false. But it did output 6. The difference between while and do while is do is going to execute the code. It's going to execute the structure of the loop at least once. And then check for the condition. Whereas if you had while in there, so if you replace this, see, a while actually checks for the condition first and then goes inside the body of the loop. This is a slight difference between the while and the do while loop. Okay, so now let's go ahead and talk about my favorite looping structure, which is the for loop. And like I said, if I would have told you guys about this, you won't be so interested in the do while or the while loop. The syntax of the for loop is simpler, straightforward, and has least number of lines of code for any looping structure. You have your for loop, but in the parentheses, you declare a variable, you initialize the variable, you also have the condition check for the variable, and you also increment or decrement the variable. All of this in one line, right? So you had I still have that example up here. No, I don't. Okay, but you know, in your while loop, what would happen is you would have the int I equal to 1 outside of the loop, and you're going to be checking the condition as the condition in the parentheses of the while loop, and within the body of the while loop, you'll have the increment I. But here, you're able to do it all at once, which makes it very convenient. I'm going to walk you through some examples. This for loop, it has int I equals to 1, and as long as I is less than or equal to the number, I'm going to keep looping, okay? And then I'm going to say sum plus equals I. So you should know this. Sum equals sum plus I. So I'm adding these numbers. Okay, and then finally I exit out of the loop, and I say this is the final sum. Now what's going to happen? So this is your starting point. I starts at 1, and I goes till a number. A number that's defined by you, the user. So you'll tell this loop how far to go. Go till 1, 2, 3, 4, 5, whatever, and then you're going to keep adding it. And you're going to keep incrementing it, and then in the loop you're going to add. So you're going to increment the sum. Sum is going to be a running number. So I say 3 is equal to 6. Right? So you can run this in your head, and it's going to be a lot simpler. And like I said, this is probably the most used loop. I still use this. The do while loop and the while loop, I use it for teaching. While loop I still use once in a while, but for loop is by far the most used loop and very convenient to use. Okay, so hopefully this is clear. Can you do it this way? What do you think? Syntax wise, it's okay. What's going to happen? Infinite? There you go. It's not stopping. Because there is no condition over there. So syntactically you can be okay, but logically you're incorrect. Because you didn't want to do that. You actually wanted to have a value that's going to end your loop. So that's all the looping structure. Now continuing on with our quest for control of the language and the way to control, the next thing up is a switch statement. Now the way you go about thinking or understanding a switch statement is a scenario based execution. Okay, so you say switch an expression. An expression is something the user might have entered, or an expression is something that you're testing against, and in that you have case 1, scenario 1. Okay, scenario 1, what do you want to do? And break. You break out of it. Case 2, what do you want to do in that case? Or the default case. If none of the cases are valid, or you don't run into them, you have a default case. For whatever reason it might be. One thing to keep in mind is the break is a special keyword. I'm going to come to this in a little bit again. I think I have an example as well. So break is going to break out of the loop. Okay? So this is a scenario based structure here. So enter an operator, plus, minus, subtract, divide, whatever. I'm asking the user to enter in an operator, and then I say, hey, enter in, 2 numbers along with it. So if I look at, it's a character char operator, and then I have 2 numbers which are floating numbers, and then I have a switch statement on the operator. So if it's case plus, So if the user entered in plus, I'm gonna say num1 plus num2 equals this. So I'm adding, and then I break out of the switch overall. Or if it's minus, then I subtract the two. If it's multiply, I multiply. If it's divide, I divide them. Or if none of those operators is something where user entered, I have this default case that the operator is it's incorrect. Let me run this. So I'm just going to say, alright, because I entered in, oh, I had an invalid input over there. Now let's be serious, and I'm going to enter in plus two numbers followed, there's a space in between. So 1 plus 2 equals 3, okay? So now you might be thinking, well, you could have done it via if then else, right? But if then else is going to make it cluttered a little bit. Case is more cleaner and easily readable. But yeah, theoretically you can do it via if then else. Okay. What else do I have? Break and continue. Like I said, we use break, but I'll show you the example of it. Break, like I said earlier, breaks you out of the loop, whatever loop you're in. If, while, do while, whatever. Any type of loop, any type of looping, any type of control, break out of there. Continue will make it continue or go to the beginning of the loop again. These are two subtle differences between the two. So, look at this. I have a for loop that goes in from 1 to 10, and the moment I see 4, it says continue. And continue, what continue should do is it should take you to the very beginning of the loop. It's going to make it loop again. So all this looping is doing for us is it's going from 1 till 10 and outputting that. But if you look here, if it's 4, then you continue, so you never hit this output statement. You see, it's got all these numbers in here except 4, because when 4 came, it went to the beginning. Now, if you want to, what do you think is going to happen? I told you break is going to come out of the loop. Let's run. 3, and as soon as it hit 4, it broke out of the loop. Right, so those are it for the switch, the control structures. Okay, take care, and I will see you in the next lecture.